Good day. This is James Aguilar. In this lecture, we have the break and continue that is under Computer Fundamentals and Programming. Break and continue are usually inserted in a loop and selection statement. A break statement. When executed in a while, for, do while, or switch statements, causes immediate exit from this statement. It is used to escape early from a loop or to escape the remainder of a switch statement. I have here an example of using a break statement. This is a for loop, and inside of that, in the for body, you have this break statement, usually inserted using the if statement. If you're going to analyze the for statement, you have this statement: for x equals to 1, x is less than or equal to 10, then x plus plus. Without this one first, the break statement will going to print the value of x, which is usually 1, and the final value is 10, so it will going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But having this break statement inside of that, usually it will going to terminate the loop or exit the loop without completing the entire iterations at x equals to 5. Thus, it will not going to print the value of 5. Usually, you will have only 1, 2, 3, and 4. And after it will going to proceed to the next statement, which is the print f in line 14. Okay. So this one will be skipped once the value of x reaches 5. Okay. This is the output. That is 1, 2, 3, and 4 only. So the rest will not be going to be printed since you break the value of the for loop when x reaches 5. Another is we have the continuous statements. When executed in a while, for, or do while statement, it escapes the remaining statement in the body of that control statement and perform the next iterations of the loop. The same example as for the break statement, but this time using the continuous statement. So here you have inserted another continuous statement using the if condition inside the for body. Again, if we're going to analyze the for loop, it will going to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But since you have inserted here at line 9 to 11, if x is equal to 5, then continue. What this will going to do is while the for loop is performing the statement 1, 2, 3, 4, and when it reach 5, it will going to skip this one. This is statement, which is the printing. Then again, it will going to proceed to the next iteration, skipping the value of 5. Okay, so this is how we use continue in a statement. Okay. But before we have the logical operator, so let us try using the break and continue in this online compiler using the online GDB C compiler. Okay, so this is the program using the break statement if x is equal to 5. Okay, so running it. So this is now the output for that. So you can see that it is only 1, 2, 3, 4. Then since you have here break, automatically it will going to skip the entire for statement. And this one is same example as for the break statement, but here is now using the continue statement. Same loop, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we have a continuous statement if x reaches 5. So let's run the program. Okay, so yeah, it may have an error, but let's disregard that. Let's focus on the output of the for loop. So this is now the output of the for loop. If you can see, you have 1, 2, 3, 4, and it skipped 5, the value of 5. Then proceed to the next iteration, which is 6, 7, 8, 9, and 10. So you have this output. Okay, so let's continue the slide. So we have now the logical operators. So for the logical operator for simple condition, usually you use this during your different topic using the for loop, the while loop, and the if conditions. For logical operator, you have the less than or equal. Also, you have the greater than or equal. Then you have the less than, the greater than, then you have the not equal. Last is you have the is equal to. As an example, you have this while loop using a simple condition wherein the counter is less than or equal to 10. If you have this condition, so it will go to perform these actions. So this is an example of a simple condition. And now we have also a logical operator for complex conditions. You have the logical AND, 2 ampersand, logical OR, you have 2 bar, and logical NOT or logical negation, you have the exclamation symbol, or we call this one as NOT operator. For the AND operator, it ensures that 2 conditions are both true before we choose a certain path of execution. If one statement is only true, so it will not going to execute the remaining condition or the remaining output. So for example, you have this. If gender is equal to 1, so this is the first simple condition. Then you have the AND operator. Age is greater than or equal to 65. This is the other simple condition. And you will have now this output or the statement inside the if condition. If this one is true and this one is true, so it will going to perform this statement. But either of this statement is false, it will not going to perform this statement. So that's how the AND operator works. AND operator, this condition is true if and only if both of the simple conditions are true. If either or both of the simple conditions are false, then the program skips the action statement and proceed to the statement following the if. Not only if, you have the for or any other loops that we use that are using this operator. A truth table is established for logical AND. So if you can see that if both expressions is 0, that means false, the output is false, regardless if even one of the expression is 0, still the output is 0 or false. But if you have two non-zero, you will have a true output. That is for logical AND. Then we have the OR operator. We use the bar symbol that is located the second function of the slash on your keyboard. If either or both of the simple conditions are true, it will execute the statement. Ensure at some point in a program that either or both of the conditions are true before we choose a certain path of execution. So this one is as an example for that. We use this condition. One simple condition, if mxsum is greater than or equal to 90, or fxsum is greater than or equal to 90. And a statement, inside of that, you have the printf student grade is A. That means if either of these two simple conditions is true, or both, it will going to execute this statement. Again, a truth table is established for logical OR. So if you can see, if both expression 1 is 0 or false, the output is false. But if you can see, If either of the expression is non-zero or both are non-zero, you will have an output. Then we have also the not operator. That is the last one under complex operator. That is the logical negations. That is simple. Enable the programmer to simply reverse the meaning of the conditions. Logical negation operator has only a single condition as an operand. Usually, we haven't used this one for a multiple conditions. Logical negations operator is placed before the condition when we are interested in choosing a path of execution if the original condition is false. So that means we want to reverse the output. So consider this example. You have if grade is not equal to the sentinel value. So usually we use negative or 1 for the sentinel value. If this is not equal to negative 1, so that means it will going to perform this statement. But if it is equal to the sentinel value, so it will going to skip this statement. You can write this process also like this. You have to equal first your grade to the sentinel value, then you can now invert the process. These two are the same. Truth table for that, you have if the given is false, it will going to have an output of true. If the given is true, it will going to have an output of false. Or if the given is 0, you have a 1 output. If the given is non-zero, you have a 0 output. Okay. For the last, we have the equality and assignment operator. Usually, some of the programmer get confused with this process. You have the double equal, that is equality, and the assignment operator is equal. So let's see the difference between the two. Okay, so we have equality and assignment operator. Usually, for equality operator, we use this one, and for the assignment operator, we use one equal only. So if you swap this operator, it will not cause a syntax error, but a logic errors. So assignment operator, these are the following example. If you want to assign 100, this is a value to the variable x, you use this assignment operator. Then if you want to assign a character C, so this is a character, a single letter, to a variable name flag, you can now use this assignment operator for that. This is your variable, this is the value, which is a character. Then lastly, we have, let's say you want to assign 2 to the integer a, you can first define the data type of variable a, then assign the value of 2. So that are the uses of the assignment operator. On the other hand, we have the equality operator. That is usually used in while for dual statement that test conditions. Even you can use it also in if conditions or if statement. So like this one, if grade is equal to 1, print A. So that is an equality operator. That means if the value of this one is equal to 1, it will go into perform these actions. So this is a logical operator. Okay. Same with this one. This is a assignment operator. You will going to assign a value of 1 to the grade. And this one on the condition part is equal to B. That means the grade will be checked if it is equal to B. Maybe a character, or B is maybe a variable before it will going to execute the printf statement, which is pass. Okay, thank you for that. And by the way, again, I am Engineer James Aguilar, and this is my lecture regarding break and continuous statement. Okay, thank you.